To graph polynomial functions, we can make a table and choose any x values that we want and find their corresponding y coordinates by evaluating our function at those x values. And so we already have this table made for us, and somebody has gone ahead and chosen some x coordinates for us to use. All we need to do is plug each of these x coordinates into our y function. And so if we do that for our -3, our first x value, we'll get something like this. Y equals -3 squared plus 2 times -3 minus 2. We can go ahead and simplify this by working it out. So we'll have 9 minus 6 minus 2. And that will give us y equals 1. And so what we've just found is that at an x of -3, our y value in our function is +1. I'm now going to go ahead and do that for the remaining y or x values here. There we go. I do want to point out that this table from Apex Learning Software has a typo here. This coordinate for x should be -0.5. And if we put -0.5 in for x into our function, we should get -2.75, which is consistent with the second table that they show you. So as soon as we have found all of our y coordinates here, all we have to do is plot each of these coordinate pairs. Remember, we've worked with plotting coordinate pairs written with parentheses before. And so if we take a look at the first one, we have -3, 1. That is going to be a dot on our graph to the right. And so we go -3 in the x, 1 in the y, and we have our first coordinate. If we look at the second one here, we have -2, -2. So -2, -2, that should be down here. This one here we can just estimate, so -1.5 in x, and almost -3, so -1.5, almost -3, that should be down here. And then we're back at 0, -2. There we are. Okay, I'm going to go ahead now and graph the remaining points. Great, so now we've got all of our coordinates plotted. With all functions, all we have to do to finish is connect our dots with a smooth curve. Please don't just draw straight lines. Bear with me, this is a little bit hard to do with my stylus pen. So we can very clearly see here that we have a graph that looks like a U. As we will learn, this is the telltale signs of something called a quadratic function.